I owe a big debt to Matthew McDole, who's going to be speaking next. You've seen this, so many software companies that have presented here, and we talk so much in abstractions. And then I get asked to give presentations to investors or business people or folks that are maybe a little less connected to the topic. And man, it sure helps to have a reference to tacos. Like I use Matthew's stories from Yum Brands more than I'd care to admit. But Matthew is a engineering leader at Yum Brands and has led, well, as you'll see, the re-architecting of some of the most foundational applications that power Yum. And he is going to give a talk about Temporal at Yum. Welcome, Matthew.
Thank you very much. Hello, everyone. I'm Matthew McDole. I'm the Senior Director of Engineering at Yum Brands for the Yum Commerce and D&T department. And I was trying to think about like what I might name this talk. What would be like a good title for this talk for me? And like one idea I had was sort of maybe like Temporal for mere mortals. You know, like today we've heard from amazing, very deep technical companies. We've heard from Stripe and Datadog. These people are literally leading the way with Temporal. They're helping shape its future. But you know, whenever we were first adopting Temporal, one of our concerns we had was, you know, do you need to be a Google or a FANG company or one of those to bring Temporal on? Are we going to be able to support this in production? You know, are we going to be able to operate in this new sort of programming model? Are our teams going to understand it? So my presentation is kind of just giving you a slice of life of our use case for how we're using Temporal, you know, what we use it for, some tips we've learned along the way, and maybe like a future use case that we're looking at within Yum. Okay, so really quick, for those that don't know, what is Yum? Yum owns Pizza Hut, KFC, Taco Bell, and the Habit Burger Grill. It's one of the world's largest quick service restaurant companies in the world. It has over 50,000 restaurants worldwide. I'm the engineering leader for the Yum Commerce platform. And the Yum Commerce platform is a set of microservices that Yum is building in-house intended to power its brands. And just to give some color to the Yum Commerce platform and size of these teams, within this dashed line box here, it's probably maybe about 70 engineers. Each pod team has maybe between 5 or 9 developers, depending on the pod, and they're split by business domain. And the commerce platform, the way that it powers the brands is really in 2 ways. One is we're intended to power the digital experiences of the brands. So if you go to KFC.com or you pull up the mobile app and you want to order a bucket of chicken, our Yum Commerce platform is supposed to power that. That way, we have one center of excellence for this across all of the brands, and we get this, the scale across all of these brands without everybody having to re-implement it. The other way is in the store. So Yum Brands has its own point of sale system, Android-based, that it's being developed, has its own kiosks, and we are supposed to be sort of that bridge between the digital world and the in-store world. So whenever point of sales need to get taxes or menus or have orders transmitted down into them or do loyalty redemptions, all of that's supposed to flow through the Yum Commerce platform. Today I'm going to be focusing on one domain within the Yum Commerce platform, the order domain, and this is where we've used Temporal. And Temporal has completely transformed our order service, and why we decided to use Temporal is because food orders are very complex. And to kind of highlight that complexity, I'm going to walk through the life of a food order really quick. So if I want to buy a bucket of chicken, I'll pull up the KFC mobile app, and these are sort of the business steps that a food order will go through. You know, at first you're going to retrieve your cart, you're going to pull the products that the person has ordered, and then next that order needs to go through a lot of validation. We need to make sure that the restaurant is still open. If their menu has changed since they placed, then we need to reject the order if they have promotions or coupons, so many different things. But if you pass that gauntlet, then we need to authorize the payment. We call out to an external payment processor. And like I said before, Yum Brands is in 50 plus countries. I think we have integrations with probably over 30 plus payment processors. We need to save the order, then we need to clear their cart, Then we need to transmit the order. So we need to get the order down into the store. And this is what that looks like. So this is the order going from our UmCommerce platform down into the store. Just really quick. Boop. Okay, so the order is gone from the cloud down into the store. That's being displayed on a KDS in the restaurant. Now these next steps here. The store confirm order is an automated step. It's a automated, yes, we have your order. But these next two are people actually pressing a button in the store, and these are advancing our order state. So the first one is I'm committing the order, meaning I'm making the food. And then this one is the food is now ready. I've finished making the food. So here I'm going to show you Brittany from KFC. She's going to bump this order, and this is going to advance this order state. Brittany's awesome. I love Brittany. So now that that's happened, then the order state advances sort of into its terminal state, the close order, and then we're going to capture the payment. It's sort of a final step here. A nuance of this is we have a clock ticking in the background for transmission timeout. We have so much time that we have to get this order down into a store. Our business rules state this, and if we don't, we need to cancel the order. We also have another timing use case here, which is auto close. It's possible for these orders to sort of get down into the store, committed, but then they just, for whatever reason, won't be entered into this terminal state. So we want to automatically close those if they don't, because most of the time that's just because somebody didn't press a button in the restaurant or there was a technical issue, but we want to ultimately capture the payment for those, so we have that. And then one more sort of thing here is we also support future orders. So this is, you see this box in this flow. This is us waiting a pre-specified amount of time until we transmit the order down into the store. So like here, you see on the KFC mobile app, you can schedule your order for the future. And KFC allows this up to 7 days out. And this is really important for KFC's business because some people will place very large orders, and they get to see these orders ahead of time, and they know how much chicken they need to prep for that day. So if you were to build this service, and how would you do it traditionally without Temporal? I'll tell you because we built this. You might create an order service and a cart service, and then what we created is an explicit state machine inside the order service. Then you'll have a data store for persisting the order in these state transitions, and then we had a bunch of timers or pollers, for the timeout use case, for the future order transmission, and then for that auto close use case. And then you start to think about reliability of this. Payment processors go down way more than we would like, especially, not Stripe, but the other ones, definitely, for sure. Transmitting the order down into the store, this is very fraught. One of our brands, I had an engineering leader from one of the brands tell me that at any given time, 5 stores don't have internet connection. So that's just like a fact of life that, the connectivity there is very fraught. Capturing the payment similarly, but this is very important because if we can't connect to a processor, or if we're having an internal issue and we're not connecting to a processor, we need to collect that payment for that franchisee because that food has left the door. So we want to make sure that ultimately, no matter what, we're going to capture that payment. But then there's a ton of other things that can go wrong. We could be having issues with the order database, the cart persistence or service could be having issues. Basically, every step of this flow can have a problem. So the usual thing that we grabbed for whenever we needed to add reliability is we started to drop in queues everywhere. So we added a payment capture queue. So this is ensuring that we capture the payment. We added a payment rollback queue. So this is for compensating transactions. If we need to cancel an order, we need to clear the auth and do some other cleanup. And then we have a transmission queue to make sure that we can get the order down into the store. And then very quickly, this starts to be the face of our site reliability engineers whenever they're faced with our very complex order platform. So we started to look for a solution to this problem. We wanted to elevate ourselves sort of out of this mess that we were in. And so our search for Temporal was really born out of a need. So in that breadth first, depth first, we definitely went depth first, and it was born out of a need for us to solve a particular problem for a particular use case. And now we're seeing use cases everywhere, but this started with the order flow. So we first looked at Netflix's conductor, we looked at SWF, we looked at cadence, we looked at step functions, we even looked at Azure durable functions. We actually didn't look at Temporal initially, we honed in on cadence, and then later found Temporal through cadence after we had done some initial work with cadence. But there's one thing in cadence that I want to call out, that is in their user docs that really, really resonated with us. I'm going to violate a presentation rule, and I'm going to read a block of text really quick. So a large number of use cases span beyond a single request reply. They require tracking of complex state, respond to asynchronous events, and communicate to external unreliable dependencies. The usual approach to building such applications is a hodgepodge of stateless services, databases, cron jobs, and queuing systems. This negatively impacts the developer productivity, as most of the code is dedicated to plumbing, obscuring the actual business logic behind a myriad of low-level details. Such systems frequently have availability problems, as it's hard to keep all the components healthy. Whenever we first read this, I felt personally attacked, because you could not more accurately describe what we had built with our order flow and the problems that we were faced. So this really resonated with us, and ultimately was why, what led us to wanting to do a POC with Temporal. So we had our original order service that I just described that we weren't super in love with, but this is processing, millions of transactions, and it is powering our business, and it's very important that nothing happens to it. So to adopt something like Temporal, it's risky, and I would just say Yum in general is probably a risk-averse company, especially whenever it comes to these kinds of things. So we need to roll out Temporal in a safe way that does not jeopardize our orders. So what we did is we stood up a feature flag, a server-side feature flag, and we stood up a POC Temporal workflow that mirrored our existing V1 order process, and it like for like. If there was not a retry in the existing flow, we did not do a retry in the Temporal, even though it would have been trivial to do so. We kept them identical, and then the feature flag allowed us to sort of have this dynamic shunting of orders into the Temporal POC process, depending on different criteria. So for us, we only wanted ASAP orders to start. We didn't want any future orders. Let's not mess with that for right now. And at first, we started just with internal users. So we specified user IDs, and then eventually did percentage-based traffic. And the purpose of this was kind of, one, to let our SREs start to get used to, this was on an internally hosted Temporal instance, to get used to owning this infrastructure, and then also for us to get used to having production orders in Temporal, and if we have to hop on a call and look at an order, we're going to know what to do, and that was one of the fears that we had. So during this POC, I'm going to kind of talk about a few things that we learned. One thing is we needed to support a synchronous flow. So the Yum order V1 order flow was very synchronous. So you hit place order, and then many of those boxes that I just showed are kind of going on in the background before the response comes. And this later we determined was a design mistake from us, so we didn't like it, but we needed to mirror it for this POC. So this was our V1 Temporal sort of mirroring thing that we did. And if I zoom in here, to simulate that synchronous process, we have this proxy workflow set up. And this is a pattern that Temporal suggests that if you need to have this synchronous behavior, you can set up a proxy workflow. But since coming here, I've heard that there's this new thing called workflow update, where I think we're going to be able to get rid of these proxy workflows, and that's great. Another thing that we learned is tuning our history shard count for people that need to maintain their own Temporal instance. We started out with 256 history shards, which ended up being pretty anemic, and we ended up doing a lot of testing, and then we ended up around 4K. But there's an excellent blog post by Mikhail Shilkov, and I contacted him before coming here, and he gave me permission to kind of plug his blog. He's a great guy. He did the most exhaustive testing ever on what your shard count should be and where you get diminishing returns and things like that. So he has amazing graphs for showing. And we did a lot of these own tests ourselves before we knew about this, but this is one thing that we learned in our sort of tuning journey of our own Temporal instance. Another thing, even the Temporal documentation says to add Elasticsearch for your visibility. And we didn't do that initially, but eventually we learned that we should definitely do that. Besides the additional features, the performance was much better. We got a lot of benefit out of doing this. Another thing that we learned was tuning task queue partitions. So the Temporal task queues, how many partitions should you have? A rule of thumb that we got from the Temporal team that we ended up using and then sort of tuning ourselves was, around 100 tasks per second per partition. So if you had 1,000 tasks per second you'd want, that'd be 10 partitions. I think that's a good starting place for people who are setting this up themselves. And then sort of the last lesson was the hardest one for us, was trade-offs on the persistence methods for your Temporal instance. We really, really struggled with this. really an RDS shop. Everybody has tons of experience with Postgres and tuning Postgres and monitoring it. But we were worried about being boxed in terms of performance, not because of our needs today, but because of our needs in the future. So we were trying to decide, are we going to need to bring on Cassandra expertise and sort of build up our SRE team muscle around this. But where we ultimately landed through many performance tests that we ran, and some of them with the Temporal team, oh yeah, this is Cassandra, was we decided to not bring Cassandra internally. We have an internal Temporal instance, but we also have Temporal Cloud, and right now our orders are going to Temporal Cloud, but we can fail over to our internal Temporal instance, and then as we sort of get further along in this journey, we might revisit this decision, but hopefully Temporal Cloud will solve all our problems. So we had done the POC, we had learned the things that we wanted to learn, and now we're ready to bring on Temporal for real. Like that POC was a very narrow slice of our order flow. And whenever we sort of did this, we wanted to outline some project goals for ourselves. What did we want to get out of this? The first is we wanted to simplify our code and infrastructure for our service. We wanted to increase our order flow reliability. We wanted to start evaluate our operations idempotency. And then we also wanted to have easier production outage support. So this first one, simplify both code and infrastructure. Let's just take one use case on this, which is the transmission timeout. I'm going to show you what we had before and then what it looked like after Temporal. So on the left is the timeout puller code that we had. And then on the right is the Kubernetes cron job that executes this every 15 minutes. And if we kind of zoom in here, what this thing is doing, it's got this thing that is querying all of the orders that might have exceeded their transmission threshold. We've got a bunch of explicit state management here for all the different states that an order can be in. And then down here, we initiate a rollback or compensating transaction if an order has exceeded its threshold. So let's dive into this. Initiate a rollback. So we have a rollback queue. And this is the rollback queue code here, which really does two things. It executes a state machine step, and if it fails, it'll get put back onto a queue to be retried later. Let's go into the state machine step. The state machine was atrocious. It had grown with our business needs over time, and if you look over here, like I could not fit this on 40 slides if I tried. It was thousands of lines long for all of the orders, states that an order could be in and all the transitions that they could go to. And then on the right here, you'll see that for this particular case, the cancel payment action would get fired. And then finally, here's the payment cancellation code that is canceling that authorization that we had. So in Temporal, all of that was replaced with this. So what we have here is we're setting up a transmission timeout timer, and then we add a future to that, and then we're kicking off two activities. One of them is voiding the payment, and I could show that, I'm not going to, but all it's doing is making a single service call. It's very simple. And then the other thing is doing a little bit of bookkeeping with saving something to a database about the order state. That's it. And then below that, we have something that cancels this timer should the transmission be successful. So if we go back to this, we've gotten rid of the state machine. All of these pollers are gone. All of these queues are gone. And I want to highlight one of these, this state machine. It's not just that we got rid of that explicit state machine. It's that our developers don't have to think in state machine mechanics anymore, right? And this is huge. This is huge. I don't know who here has been on an outage call where you're trying to debug a state machine for an order live. It's very stressful. I don't recommend it. Definitely don't do it. All right, so the other project goal we had is increase our order flow reliability. So these are all steps in this flow that we would want to retry. Assuming we have not hit our timeout, we would want to retry them. But because persistently retrying things was difficult, it required us standing up new queues, and you don't always do the right thing. If the right thing is not easy, people won't always do the right thing. So what we ended up doing is only the most important of these, like capturing the payment and maybe the order transmission. We would stand up the retry queues and the right retry behavior for that. But now that we can just literally slap retry policies on our activities, developers do the right thing now. So now that it's so easy to retry these, almost every single activity has an appropriate retry policy attached to it. This one is interesting. So this isn't Temporal specific. We didn't need to adopt Temporal to do this, but in adopting Temporal, our developers, it sort of forced us a little bit to start to think about our operations idempotency across our platform more concretely. So what I mean then by that, so what is idempotency? This is an idempotent operation is one that has no additional effect if it's called more than once with the same input parameters. And Wikipedia has a cool example here where this is a train control board and it has an on and off button. And if you press the on button twice, that second on does nothing. If you press off, it'll turn it off. If you press off again, nothing happens. So both of those buttons are idempotent. Our services are starting to adopt this RFC that was suggested for adding idempotency keys to our services. And I'm going to give a use case that we use this for here. So here's our order workflow. Here's some of the activities that it executes. And authorizing a payment. Some payment processors support idempotency keys. Not all of them do. So especially some of the smaller ones. They don't have idempotency semantics. So what can happen is if this happens to fail and then it gets retried, you could have a double authorization, or later on we might have a double capture, which is a bad customer experience. People are getting charges that they did not expect. So now, following that RFC, we now, in our workflow, generate idempotency keys. We pass those along to the appropriate activity, and then those get passed to the service that they're getting called for. And then if this gets retried, it's fine. Our payment wrapping service is not going to allow and authorize that with the same idempotency key. So this one is pretty simple, simplified production support. Whenever we have an issue with an order, somebody calls up, they have an issue in order, or we're on a production call and we need to look up an order, this is a game changer for us. So we were getting ready to build our own saga log before with our old platform and our old system where you could go into a web and look up a saga log. This almost eliminates the need for that because now we can literally just plug in the order ID and then at a very high level see the activities that executed and when and the details and the parameters for them. So this is a game changer for us. This is really great. Before with all of those deployables, order had like 4 or 5 or 6 deployables. You're now querying logs across all of them, trying to see what state a particular order is in. That situation is gone. Okay, so order has been going great for us. It's going really awesome. If you order chicken today on the KFC mobile app, you're executing a temporal workflow. Next year, we plan to bring Pizza Hut and Taco Bell onto the platform. Hopefully, we'll get it done by Q1. But then the hope for that is that whenever you buy tacos or pizza or chicken, it's going to be cool. You'll get your phone and be like, oh, I just did a temporal workflow. The next use case, this is just a use case. I want to give some color for where we're looking next. So we have our own menu management platform. So menus are a big deal, and the domain of restaurant menus is actually very deep, way deeper than I thought. I remember in my interview, there was all these questions about like menu type questions, and I was like, well, what's in a store menu? No, I feel like menu and menu design are like 60% of my job. But if you make an edit to a menu and you want to publish that, we'll publish it obviously into our own eCommerce platform, but then we might want to translate and then publish that out to food aggregators. And we are integrated with worldwide probably like 40 plus different food aggregators. So us being able to isolate all this logic into just distinct activities or workflows is going to be really powerful, and then we'll just be able to select which ones a particular brand and market utilize. And then we need to get the updated menu down into the store. And something that's kind of interesting is you might want to have like maybe an eventual consistency check here. It's kind of important that all of these menus are the same. And it's okay if they're out of sync a little bit, but eventually you do want them to be consistent. So if we have an order source that we failed to update, we might want to do a compensating transaction that would roll them all back. Because you don't want to have orders that don't have a product or do have a product that does not exist down in the store. That causes customer issues whenever they go to the store, or it could cause failed orders. So there's that, and then there's also scheduling. So in our menu management platform, whenever somebody's publishing a new menu, it's going to be really convenient if somebody can say, at Christmas at midnight, I'm going to schedule this. And Temporal's durable timers are going to make that really easy. So in summary, we deleted our massive state machine. Tons of explicitly maintained queues are gone. All the pollers are gone. All those order deployables are gone. Our robustness is better because it's very easy to do the right thing with retrying activities. Our performance is much better, and our throughput of total orders that we could execute is we're set up for the future. So that's my talk.
Do you have time for a few questions?
Yeah.
All right, we have a couple from the audience. So first, just kind of order of magnitude size. This one was asking about how many workflows are completed daily. Can you give someone a context, kind of like today it's North America KFC, and then kind of what you envision it might be eventually?
Yeah. So I'll say I don't know if I can give global numbers, but I'll say that for North America across all three brands, you're probably looking around maybe a little under 1 million workflow executions a day.
Mm-hmm.
Yeah.
Excellent. And then another question we got was around measurement of success. You kind of talked about a lot of qualitative criteria for success. Were you asked to produce some kind of metric or something that said, okay, look, this is why this transition's better? And what were those metrics? How did you measure?
Yeah, I would say that our brands are very sensitive to outages. Like you'd think, like, oh, it's just fast food. Like, is it really mission critical? But to these brands, it's very important. And having a bad customer experience of somebody maybe placing an order that ultimately fails, but they don't know about it, and they get down into the store, they've driven there, that's a big problem and can cause a lot of customer friction. So that's a measurement of success for us, is increasing the order robustness and reliability there.
Probably not a lot of share of those, are you?
Yeah.
Yeah. All right, that's right. So you actually do that. You have a measure of like how many orders don't successfully complete, and you have a before and after from when you teed off your flow to the legacy system versus the temporals.
Yeah, and I would say the other thing is scale. So in the aggregation of this new UMCommerce platform that all of the brands are moving on to, we wanted to make sure that we could appropriately handle all of the order scale that we're going to have whenever we bring all 50,000 restaurants onto it. And that's why we're doing massive performance tests despite only having one brand on it and our load not being that high right now. Because we're planning for what it's going to be in a year and a half from now, not what it is today.
Right on. Another question. For payments, when there are outages or the point of sale goes down, what kind of priorities do you make about the risk of collecting payments versus pushing the order through?
Pushing the order through.
Yeah.
So I think it depends on order type also. If it's an ASAP order and we can't get it down into the store, there's very tight restrictions. We're going to fail that order fast. If it's a future order and the transmission's not due for 3 days, but we can't talk to the store right now, it's okay. Like, we're not going to fail the order immediately. We'll wait a little bit of time, and then eventually we'll have a threshold for, as we approach that date that order was placed for, we might fail the order then. So
just to add to that, because I think I get the question asker is getting at. So, for example, there's certain shopping cart experiences where when you check out, they will go so far as to even ship your goods before successfully collecting payment, because they'll kind of use some risk-adjusted basis to say, oh, it'll probably work out eventually. Do you allow for that, or are you like, until I've got the authorization, no one's getting their two-piece?
Yeah, until we get an authorization, it's not even an order in our system.
Okay.
Now, we will hand out food before we've captured, and that can cause loss of revenue there, but until we get that payment authorization, the payment doesn't go through.
Right.
Now, there are brands that take cash orders, and with that, there is the risk that somebody could place a cash order and then not show up for their food, and then obviously that would cause a loss.
Right on. Okay, I like this question a lot. Okay, so do you feel as an engineer now that you are using temporal as an abstraction, that temporal takes away the fun chaos? There is fun.
I had no gray hair before.
There's two kinds of chaos, folks. Do you ever feel less visibility or less control because you're kind of living in this abstraction?
Maybe initially we felt less visibility because we weren't good at, experts in getting visibility into temporal. Something we're getting better at, and now with Temporal Cloud and the dashboards we'll have there and the new metrics endpoints, I'm hoping it'll get even better. But yeah, maybe there was some concern about lack of visibility compared to what we had before with our bespoke system at first. But
right on. Okay. Practical question. Are there any considerations that you would share about running temporal internally, which you've had experience with, versus cloud? And you should probably maybe share a bit about timelines, how much time you've had with each, too. Would be great.
Okay. We've had temporal internally maybe for about 8 months. And we've blown up that stack multiple times and rebuilt it. We've ran Cassandra maybe for 4 or 5 months. We started out with Postgres, ran Cassandra, then went back to Postgres. And all the while, like, we're just turning on and off orders that are going to Temporal. Yeah, but I think our SREs are starting to get used to it. One of the things that's important to do is Temporal has this release schedule that's maybe like every 6 weeks or so, and it can be easy to maybe fall behind that, and you kind of need to apply those in order. So that's something that your SRE teams need to kind of stay on top of and get those updates applied.
Right on. Okay, implementation question. Does the state that's representing orders live in Temporal or in external databases? And how are you thinking about how that might evolve?
Yeah, so there are order records in a database, and one of the Temporal activities is creating that order record and generating that order ID. I would say the state for an order is mixed between what's in our order database and what is in Temporal. Evolving is an interesting question. This is something that I feel like whenever you first come into Temporal, you think about things very procedurally, and you think about it sort of as executing procedural code, which is a good use case for it. But where I think like the next level of thinking is thinking about workflows as entities, and this is something I've been talking to Temporal people like Mike and Maxim about, that the Temporal workflow being the entity. So if you have a cart service, the literal cart is the workflow, and we're starting to look at things like this, but I would say we're not quite there in our journey.
Yeah, that's a great encapsulation, and that's a progression that we've seen in a lot of other engineering teams. Another implementation question: what happens if rollback fails? It's one of your rollback steps.
So eventually it'll get dropped into like a dead letter type queue thing, and then the order team will go and they'll handle those orders that were unable to roll back. But the rollback process can go on for some time.
Right on. Okay, let's see here. A bunch more questions. I've done them out of order, so hang on. Okay, another practical ops question. How do you handle failover between Temporal Cloud and your own instance?
Yeah, so today it's a environment configuration variable, and we'll do a hard switch between our local and cloud. And there's no state replication between these instances today. So if there were in-flight future orders, those won't process. Like, example, if there was a temporal cloud outage and we had future orders going on, those would not continue to process, but we would be able to take new orders whenever we flip over. But yeah, we're interested in the future of temporal cloud and its multi-region capabilities. So
yeah. No, that makes sense. And by the way, and what also, just as an aside from what he's describing, this is a common one popular failover model. The temporal server itself is highly available, but one kind of poor person's version of a failover is you can have a whole separate namespace, and then you can redirect your traffic that could be in a different region or what have you. And then the chunk of the orders in flight, those are going to be frozen until that comes back up, but everything else keeps going. And so it's a relatively simple implementation. So let's see here. We still have plenty more questions. Let me get through. Let's see here. If a payment authorization succeeded on the processor side, but the TCP response connection failed, will the idempotency key prevent it from being processed again?
So this is essentially if the payment service doesn't know that it succeeded, right? That the authorization succeeded.
Let me reread to be careful. If a payment authorization succeeded on the processor side, yes, auth succeeded, but the response connection failed. Yes.
Yeah, in that case, no, we would not be protected from that because we won't commit the idempotency key until we have positive confirmation that an authorization would occur. So in that edge case, it would be possible for double authorization if the payment processor did not support. Okay.
How long do you keep workflows, and what kind of infrastructure is needed to support the volume of workflows that you keep around?
So after they're executed?
Yes, let's assume.
Yeah, okay. So 3 days, I think, or 2 days in temporal cloud. Today, we keep them for 30 days in our internal temporal instance. And we don't really need them. They're used for debugging after they're done. And at first we freaked out like whenever we were weighing temporal cloud costs, and like we wanted to keep a ton of history. But in practice, we almost rarely ever look up an order past a day or two. So it's fine for us.
Ooh, this is a product requirements question from the audience. What do you wish point of sale providers would do beyond item potents?
Point of sale providers.
Yeah.
Well, this is interesting. So we have our own point of sale team that builds their own point of sale device because we were dissatisfied with many of the point of sale providers out there. Many of them are not built well for modeling. Like, for example, modeling pizza. Pizza is weird. Menu modeling pizza is weird. And if you've ever seen the ham-fisted way that sort of generic menu point of sales will represent pizza, it's not great. So by us building our own with our own menu models, we can have this first-class experience that we want.
Very cool. Okay, so two kind of somewhat related questions. Sort of the more specific question was how you think about cost. So you had this homegrown system, queues and whatnot associated there. You had Temporal that you ran yourself. Then later on, you're using Temporal Cloud. So 3 different sets of infrastructure over time. How aware were you of the cost of these things? And was like one wildly different than the other? Were they all kind of the same? That's kind of the first part of the question.
Yeah, I would say right now we're not in cost savings mode because we're still maintaining an internal temporal cluster. So even if you add the temporal cloud cost in our internal temporal cluster, it's probably slightly higher than our previous costs. But I don't think that is going to be a long-term state for us.
Yeah.
And how we view costs, for example, this workflow is directly attached to revenue. So for us having orders be reliable, that's worth money to us. Now, there are many other workflows that we have that if we were to spawn a ton and ton of workflows that don't have direct revenue attached to them, we might be more price sensitive for those. And for those, maybe we might consider, if Temporal Cloud wasn't price competitive, like, okay, well, we might just run those in our internal temporal cluster.
I'm trying to find this other question. It got voted up, so it got resorted. Here we go. It got voted up higher, which was, have you then had to have that conversation about Temporal in terms of that sort of overarching financial benefit, where whether it's measured in revenue or customer experience or productivity or what have you, or is this sort of below that particular radar?
I think it's a little bit below that. I mean, in selling Temporal to my senior leadership, it was around. It was less about cost, and it was more about preventing outages, increasing our availability for our brands. So that was the big selling point, and that's worth a lot to us. So if we can maintain, 3 or 4 nines or whatever we would maintain, like that's worth a lot of money to the brands for sure.
Very cool. Well, it's been an excellent talk.
Yeah,
Very grateful.
Thank you.